Hey everyone, today we're going to do our Unit 6B review over trigonometry, finding missing side lengths and angle measures of right triangles. For this review, for the whole thing, you are going to need your calculator, so I have mine here. And we need to know these three ratios. When you're finding a missing side length, we're going to use regular sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. When you're finding a missing angle measure, however, it's still the same ratios, only this time you're going to be using inverse functions, sine with the little -1 there. Now opposite, hypotenuse, and adjacent all come from the right triangle that you're looking at. So whenever you look at your triangle, wherever the right angle is, so wherever that box is, when you go across, that has to be hypotenuse. And then, so on this triangle there's a theta, but you can think of that as the x. So here would be whatever degrees they give you. When you go across from that, that is opposite. And then the only other side left over is going to be your adjacent. Okay, so on this review, like we always do, I'm going to do the example problem, so that's all the odd numbers, and then the even numbers is for you guys to practice. Okay, so let's look at number 1. I want to find x. X on this one is a missing side length. So that x represents this side right here. So I know I'm going to use my regular trig ratios. So now let's look at what we have. So if this is my right angle, when I go across, 21 has to be the hypotenuse. Okay, and then this is my angle, like that's the one that has a number, 38. So when I go across here, this one's going to be opposite, but that one is just blank. So the only thing left over is that x has to be adjacent. So I want the trig ratio that has adjacent and hypotenuse. So when I look at my patterns here, that's going to be cosine, adjacent and hypotenuse. Okay, so let's set this up. Cosine, parentheses 38, so I'm using the degrees that they gave me, equals adjacent over hypotenuse. So that is going to be x over 21. I want x to be by itself, so this 21, in order to move it over, I have to do opposite operation. Right now it's dividing, so we're going to multiply by 21 on both sides, which now gives me 21 times cosine of 38 equals x. So this part right here, we're going to type that into the calculator. Okay, so here's my calculator. I'm going to go to the regular calculator page. Make sure that up here in the top corner it says degree. If it doesn't, try clicking on it and it should change between radian and degree there. If that doesn't work, go to Doc, Settings, Document Settings, and this second one should say degree. Okay, but now that I have this set up, I'm going to type in this expression, 21 times, there's a button right here that says trig right next to the 7. Click the one that we need, cosine 38. Okay, so I get this right here. We're going to round to the nearest tenth, so I'm going to say x equals 16.5. Okay, now let's do number 3. Again, this one is a missing side. See where the x is at here? So let's label these sides. Here's the right angle, so when you go across, this side right here has to be the hypotenuse, but that is blank. Then 23 is referring to this angle here. When I go across, that 25 is opposite, which means that the x is adjacent. So when I look at my trig ratios, I want the one that uses opposite and adjacent. Okay, so up here, here's opposite, but that's hypotenuse. Opposite and adjacent. So we're going to use tangent. Okay, so tan, parentheses 23, so always the angle, equals opposite over adjacent. So that's going to be 25 over x. Whenever x is at the bottom, this takes two steps. You would have to multiply both sides by x, and then you would divide by tangent. So there's a little bit of a shortcut. Whenever x is at the bottom, just switch the places of these two things here. So this is going to become x equals 25 divided by tangent 23. Okay, and then now we're going to type that into our calculator. It's still already set up. So 25 divided by tangent 23. And that gets me 58.9. Okay, number 5. So now when I'm looking at this one, x is an angle. So when we solve for this one, we're going to have to use our inverse functions. Let's label those sides. This is my right angle. When I go across, that would have to be the hypotenuse, but it's blank. Then if this is the angle that we are looking at, when you go across, that 37 has to be opposite, which means that 8 has to be adjacent. So this time, since I'm looking for a missing angle, when I look at my notes at the top, I'm going to look at this side. And the one that has opposite and adjacent is this one right here. So we're going to use tan inverse. So x equals tan inverse, so the little -1, of opposite over adjacent, so 37 over 8. Okay, so this one is actually a little easier because there's nothing to move around. You could just type it in like that. So I'm going to press my trig button and make sure that you're selecting the one with the little -1. So that's the bottom row. Tangent 37 divided by 8. And that gives me 77.8. So that angle is 77.8 degrees. Okay, now let's look at number 7. Okay, again, when I'm looking at this, x is an angle, so I know I'm going to use my inverse ratios. Okay, here's my right angle. When I go across, that 27 has to be the hypotenuse. Okay, so here's my angle that's labeled. That's not the right angle. When I go across, that needs to be opposite, but that's blank. So the only thing left is that has to be adjacent. Okay, so I'm going to look at my trig ratios. Which one has adjacent and hypotenuse? So this one right here. So we're going to use cosine inverse. Okay, so x equals cosine inverse of adjacent divided by hypotenuse, so 16 over 27. Okay, and then we're just going to type that into our calculator. Cosine inverse 16 divided by 27. And I get 53.7. Okay, so that is the front of the page. Finding missing side lengths or finding missing angle measures. Okay, now let's look at the back. This is going to be word problems. So it's still the same trig ratios. It's just now we have to read and set up our own triangles. So for now, I went ahead and I put pictures on there already. We just have to label the pictures with the numbers that we have. Okay, number 9. Sarah sights the top of the Statue of Liberty at an angle of elevation of 65 degrees. Okay, so that first sentence, here's the top of the Statue of Liberty, here's Sarah. So from where she's at and she's looking up, that makes an angle of elevation of 65. So that is this part right here. That's my 65 degrees. Then it says, if Sarah is 5 feet tall, so I'm just going to write a 5 next to her. She's 5 feet tall and is standing 140 feet from the base of the statue. So if this is the base of the statue, I want this part right here, so that's 140. What is the height of the Statue of Liberty? So height means up and down. I want to know how tall it is. So I'm going to put an X right here since that's what I'm looking for. But just be careful with this, because this triangle, see how it's kind of floating in the air? When I find X, all I'm going to be doing is finding this part right here. That's not the whole height. I still need to have this little part. So that's why it's important to know that she's 5 feet tall, because whatever we get, we're going to have to add 5 to it. Okay, so now let's see what we have. This is where the right angle is. When I go across, that's the hypotenuse, but it's blank. Here's my angle of elevation. When I go across, that's the opposite side, so the statue is the opposite side, which means that that horizontal distance has to be the adjacent side. So opposite and adjacent, that is tangent. So tangent of 65 equals X over 140. Okay, and then we're going to multiply both sides by 140. And let's put that into the calculator. So 300.2. Okay, but remember what we said? This X that we just found is just this part. If I want the entire height, I need to take into account her height as well. So she is 5 feet tall. So we're going to do 300.2 plus 5 gives me 305.2. So that's how tall the statue is. Okay, and then last, let's look at number 11. The angle of depression from the side of a cruise ship to the anchor at the bottom of the sea is 32 degrees. Okay, so here's my cruise ship. So from here to the anchor, they're saying that that's 32 degrees, but that's an angle of depression. So you have to think of this as a horizontal line straight out from here. This is the part that they are saying is 32. But because they are opposite adjacent, or not, sorry, not opposite adjacent, they are alternate interior, that means that this angle is congruent to this angle. So I want to move that angle inside of my triangle here, so that's 32. Okay, from the bottom of the ocean up to where the anchor exits the ship is a height of 50 feet. So height would be up and down. Find the length of the anchor chain. So I want to know how long this chain is. I want X there. Okay, so now we have to see what we have. So now I'm paying attention to this angle here. When I go across, that 50 is opposite. If the right angle is right here, when I go across, that X is hypotenuse. So the trig ratio that uses opposite and hypotenuse is sine. Sine of 32 degrees equals opposite over hypotenuse, 50 over X. Because X is at the bottom, we could just switch it with the trig ratio. So X equals 50 over sine 32. And then now let's just type that into the calculator. And I get 94.4. So that chain is 94.4 feet long. Okay, so that was 6 problems that we did together. Now I want you to try those even numbered problems, so that's 6 more problems just for the practice. And remember, we have a test tomorrow.